0. Blast off. Okay, we're here. All right, so what we're going to talk about is solving we're going to do a few things. One-step equations, briefly, because everything hinges on understanding this. And then we are going to talk about two-step equations, because they are so simple once you understand one-step equations. And then we are going to talk about multi-step equations. And so when you take notes, you write everything down that I put on the board. That's the best way to take notes, all right? Or in Michael's case, photographs, right? But don't let me erase anything. You guys all know that, right? Michael sometimes takes pictures of it, so instead of writing it down, so don't let me erase the board until he's had a chance to take pictures, okay? Because I'll forget, and I'll just say, can I erase it now? And you're gonna all say, no, right? Okay? Okay, so we're gonna start one-step equations. This is the first thing we're gonna do, one-step equations. I'm gonna write a few things. Let's see, we'll have to say x plus 4 equals 10. Then let's say 5x equals 35. And we'll, oh wait, I forget, I don't have a whole board here. What do I have? I should have started, okay. That's okay. And then I have 1/3 x equals, I don't know, 6. These are the only one-step equations that you'll ever see, the types, right? You really want, well, I mean, you might see a few others. There's a few others, because you have square roots and things like that, right? Right? I could see Mira was about to disagree with me, so but you're right, I'm wrong. Right? But in terms of solving simple equations, this is pretty much what you're going to see. And so they're really easy. And you know in your brain immediately the answer to this one, right? But what you have to do is you have to, what I'm trying to teach you is a process. And most of you already know it, but if you don't, that's fine. You're going to learn it really fast. The process is what's important, because these are simple. I'm showing you the process on the simple ones where you already know the answers, right? You might not know the answer to that one, but you definitely know the answer to these two. I would think everybody does. Well, so let me get to, I'll get to that one in a minute. You're right. You got the answer, right? So you know it. So this one though, what would I do to solve for the answer? Not to say the answer, but to solve for it. London.
I will subtract 4 from the left side.
Okay.
Subtract 4 from the right.
So my goal, and this is my goal always. This is my goal. Get x all alone, right? And another way to say it is isolate x, right? That's your goal. So what is in the way of x being all by itself? I want to say x equals, not x plus 4 equals, so that doggone 4 has got to be removed. So if somebody added 4, because last night x was all by itself, just the way it was supposed to be, and then sometime in the middle of the night, somebody came in and they added 4 to my x. Really, really pissed me. I mean, excuse me, made me greatly displeased. Okay, well, this is on video, right? Okay, right? So they added 4 to my x, right? Doggone it! So we're going to undo what they did. They took away, I mean, they added 4. I'm going to take away 4 from my x. So whatever sign I put here has to be the opposite sign that's there. So I'm going to take away 4. But whatever I do to one side, I have to do the other, so I'm going to take away 4. Everybody gets that, right? Fist to 5. Everybody should understand that. Okay, so all I have left is x. The 4 minus 4 is 0. I don't have to write that. So I have x equals 6. I'm done. It's called one step because this is the only step I had to do. I subtracted 4 from both sides, and I got my answer. So Pretty piece of cake. Fist of 5 on one step, these kind of one steps, right? You guys get them? Pretty easy. I'll do one other. Let's say I had x minus 2 equals 8. Last night, x was all by itself, doggone it. And somebody came in and they subtracted 2 from my x. I have to undo that. So what am I going to do? I'm going to add 2, right? I'm going to add 2, but I got to do it to both sides. So I have x is equal to 10. Right? Pretty straightforward. Now I'm going to go over to this one. What is the 5 doing to the x? It's times, right? Whenever you see, you don't see a plus or a minus or a times or a division sign symbol at all. If you don't, that's because of the shortcut of algebra. Algebra is a shortcut method to math, right? 90% of what algebra is shortcuts, right? And so there's the long way, which sometimes you do to remember it, to remember how to do something, but there's a ton of shortcuts. And one of them is to realize if there's no operation, like add, subtract, multiply, divide, it always means multiply. So I have a 5 and an x, it means multiply, right? The only time if you had two numbers, you wouldn't want to put 5 times 0 is 50, right? Because it looks like 50. You know, if you wanted to be 5 times 0, you have to put a dot in there because they're both numbers, right? But if it's a number and a variable, you don't need the dot at all. So 5 times x is equal to 35. X last night was all by itself. Somebody came in and they multiplied my x by 5. How do I undo multiplication, Tia? Divide. So I'm going to divide by 5. Another way to think about it is I want 5x to be 1x. 5 over 5 is 1. So that would be 1x. I'm going to divide by 5. All right, so these cross out. X is equal to 35 divided by 5, which is 7. Fist of 5. Do you understand this?
Yep.
Does that make sense? Fist of 5? Awesome. Last one. We have 1/3 x equals 6. 1/3 x equals 6. I want to turn that into 1x. There is a rule about fractions. A fraction times what equals 1? Because I want it to be 1x. What would I multiply a fraction by to get 1? Andrea?
It's opposite.
Almost. See, opposite would be positive and negative, right? But you're close. You're really close. What's that called? What's that called? When you flip a fraction upside down. A reciprocal is what they call it. So if I multiplied this by its reciprocal, 3 over 1, right? That's the reciprocal. I'd have to do the same thing here. Do I have to write 3 over 1 here?
No.
Do you guys all agree that 3 over 1 is the same as 3?
Yeah.
So I could just write 3 here, right? Okay, so then, look, 3, that's 3 over 3, or I could just say 3 goes in 3 once, 3 goes in 3 once. Oh, 1 over 1x, that's just 1x, or x equals, oh my God, Ben, you were right. It's 18. Good guess, buddy. That was a great guess. I'm just kidding, all right? Good job. So anyways, that's how you do those. There's probably not going to be much of that on the homework tonight. We're going to go into fractions in a little bit. But I'm going to focus a little bit more on these. Now, you won't find any one-step equations. Well, there might be one. But there's probably not going to be very many one-step equations. So now we got to look at... Don't erase what part? Oh, don't erase. You're right. See, I told you I would do that. All right. Okay, I just erased that one. You know how to do this anyway, so you're fine. Okay. All right. So now, so we have just finished. Where is my red pen? You guys agree with me? We have just finished one-step equations, yes? All right. So now we're going to look at two-step equations. When does this go till?
10:30.
Oh, thank God. 10:25, right?
Oh, yeah, 10:25.
Yeah. Oh, good. Okay, good.
So, yeah.
All right. So now I am going to change this equation into a two-step equation. Here we go. I'm going to put a 2 here. Okay? Now suddenly I have to change something here. But the important thing to understand is with a two-step equation, you will do exactly the same thing you do first with a one-step equation. You do not worry about the 2 yet. Right? The 2 is multiplied times x. It's married to x, basically, right? I don't know. Multiply, marry. They're a thing, right? Leave them alone, right? The 4 is the thing you want to get rid of, right? So we are going to subtract the 4 just like we did when it was a one-step equation. We're on a two-step equation, you want to say 2x equals, right? You don't want to say 2x plus 4 equals, you want to say 2x equals. You want all the x's alone. So you're going to isolate all the x's first. So we get rid of the 4, and what do we get? We get 2x equals 6, right? 2x equals 6. Oh my God, what is that? That is a one-step equation, just like this one. Oh, piece of cake, right? Piece of cake. So what do I do? Gideon, help me.
You divide 6 by 2.
Right,
You
I'm going to
each
divide
side by 2.
both sides by 2, right?
Because
2,
what you have to do
2,
to one side, you can
and
do
this is what I
2
really want to see this. I want you guys to write these out. I don't want you to just do this in your head. It drives me wacko when people just write the answer and they get it right. And I have no idea if they know what they're doing, right? Great guess, right? That's what I have to say. Because I don't know what you did. So x is equal to 3. That's a two-step equation, just to 5. Do you get it? Do I need to do another one, or is that good enough?
Good.
Is that really good enough for everybody? Yes. All right, so we have finished two-step equations. You guys agree with me? Yes. Gideon, you have a question.
Oh yeah, couldn't we do 1 and 2-step equations by using the scale method?
Oh, you can do all of these with a scale. All of these with a scale. But the scale is to help you understand that it's a balance, right?
And
Whatever you do to one side, you have to do the other. Otherwise, it gets off balance, right? And that's why I use the scale. The scale, though, ironically, you can do much harder problems than these on the scale, and third graders can do it in no time. They're so easy with a scale. So you have to think what we're doing is we're doing exactly what we would do with a scale. If 2x plus 4 equals 10, I have 2 green things plus a 4 equals 10, which is 6 plus 4, right? I'm going to take a 4 away from both sides. I have 2 x's equals 6, right? So then I have to say, what plus itself equals 6? 3 plus 3 equals 6, so x equals 3. Boom.
Oh, and by the way,
That's the scale.
it might not hurt to get an external mic rather than using the mic on the webcam
Is
because
it
I
not?
had my volume at full blast
Seriously?
when using high def headphones and I could still barely hear you.
Has anybody listened to the things before?
Yeah,
Too?
I did.
Is it the same thing for you guys? Really?
No, I mean, not as much as Lydia.
Because
but
these
it
are
is-
supposed to be really good, because they have 2 speakers. That's why I bought it. It's like 70-something bucks. They're the most expensive ones. Anyways, I'll figure it out. But keep me informed as I figure it out, okay?
Okay.
Because I may have to use it until I get an external mic.
Okay.
The external
And it might
mic
just be
is,
something as simple as adjusting the mic or calibrating the mic so
That's
it's
true.
like auto adjusts.
that's true. I'll just see.
That's what it's
All right.
on my laptop.
So now we're gonna go into multi-step equations. I have 4 minutes to go into multi-step equations. So I'm gonna, Michael,
Uh-huh.
do you need any of this? Do you know this so well that you don't need it?
I took a picture of it.
You rock.
I mean, I did it anyway.
You rock. Yeah, I know you know it. But, okay. So now I'm going to leave this for a second, right? I am going to do a new. Okay. Now we're going to go into multi-step equations. So let's say I had 2 times x plus 4 equals I don't know 16.
Use the distributive property from the x and 4.
All right, so there's a thing called the distributive property, and I don't know how far I can go. I can go right. Okay. So distributive property. I think Nate talked about this. Am I right? So if you had A times B plus C, that would equal, you would actually draw these little arcs, right? A times B plus A times C, right? Sort of like an elephant snout or something, or a Joker's hat or something. But anyways, A times B is just AB plus A times C is AC. So if I was using a real number, I mean something like this, plus 6, that would be 2 times x is 2x, plus 2 times 6 is 12. That's distributive property, right? I think you guys all know that. So now we're going to use distributive property. That's our first step. We have to use distributive property before we can move forward. So, what is it?
2 times x, 2 times 4, which is 2x plus
2x plus 8 equals 16 now. What do I have now?
8. A two-step.
I have a two-step equation, right? So what do I do?
You
Ben.
subtract by 8.
Subtract 8, right?
Yeah, and then
2x are married. We're going to leave them alone for a second. We're subtracting 8, subtract 8, boom. 2x is equal to 8. Now we have, what's this called? One-step equation. All right, Mira, I know this is hard for you, but what do you do? Oh my God, you're right. Okay, you divide it by 2. X is equal to 4. Look at that. So how many steps was that?
That was a lie. Let's just say that, it was a lie.
2, 3.
So that was 3 steps. All right, so now I'm going to erase my 2-step. All right, and we're going to do one that's slightly harder. How far can I go? I think like here. So let's say we have 4 times 2x minus 1 minus 6x equals 2 times, well, let's see, I better not do 2, hang on a second. Let's just make it minus 4x, sorry. That's a minus 4x, in case you already wrote it. I just changed it to 2 times x plus 2.
Okay.
All right, there's my equation.
That can barely fit on the
Okay? All right, so the first thing, yes? Question? Yes. We're out of time? Okay, too bad. The bell didn't ring. Sorry, okay, shh. Okay, we're gonna use distributive property, right? I'm gonna do this, I do my arcs so I don't forget. Now what happens mostly, I'm just gonna tell you right now, what a lot of people do is they'll do this. They'll say 8x minus 1. Oops. They forgot to distribute the 4 to the second term, right? It's minus 4, right? And then I have minus 4x. And I have equals, I got to do my distributive property here, 2x plus 4. All right, so here's my scale. That's my balance scale, right? It's like this, right? So I want to see, are there any like terms that I can combine on this side? I have 8 x's, and I take 4 of them away, right? So immediately I have 4 x's. So I'm going to have 4 x's minus 4, and then I have my equal sign, and then I have 2x plus 4. Right? You with me?
Yeah.
Now I see a problem. I see I have x's on both sides of equal sign. I cannot isolate my x with my x's on both sides. It's absolutely impossible. Don't ever let anybody tell you it's impossible except me. It's impossible. You have to get the x's on the same side. Lila.
Okay, so you want to divide, or so you try to get something off of that you have to subtract 2 from the,
So 2 or 2x.
2x.
I have to subtract this to, I'm going to get rid of this squiggly line here. It's driving me crazy. I'm subtracting 2x. Did the bell just ring? Did you just hear it? No. Okay. Subtract 2x. Subtract 2x. Wait, guys, just stay quiet. Listen. So now suddenly 4 x's, 4 apples minus 2 apples is just 2 apples, or 2 x's. Minus 4 is equal to, that crosses out now, 4. See what I'm doing? It's just like the scale. I just took 2 x's away from both sides. See that? Okay, we're almost done. We're almost done. Now this is a 2-step equation, right? So you add 4, you have 2x is equal to 8, divide by 2, x is equal to 4. All right, so Michael, take a picture.
Thank you. Wait, what about our homework?